Okay, guys, I got cut off, and so hopefully now I can actually see the time. So your assignment today won't be actually doing what the problem says. You will be mostly just working on drawing a histogram, finding median, mean, and mode. Mode is the only thing that you have to do it by hand. You can't use calculator to find mode. And describe whether this distribution is best described with median, mean, or mode. Okay, so let's get into that a little more. So this one, I think I got cut off when I was saying the median would be better measurement for this distribution, number 3, because it has a skewedness. So let's go back to the median and mean and compare. And I knew, without looking at the graph, the histogram, I knew that it would be skewed to the right. And the reason I knew was because the mean was 33.4. But if you look at the median, it's only 23.5. So do you see how there is the mean is greater than median? So when this happens, it's because there were higher extreme values that would affect mean, but median wouldn't get affected, right? It doesn't matter if your n values are 100 or 1,000. Let's go back to that extreme example of 10 students who everyone failed except for one person, right? So I'm going to write it in order so I can find median. So 0, 0, 0, 0, 0, 0, 0, 0, and the last person is 10. And it doesn't matter if this number was 10. Oh, sorry, it wasn't 10, it was 100, right? Because it was out of 100. If this person got 100 or 50, my median would be still 0, right? Because it's a middle number between the 5th and 6th number. So median doesn't get affected by what the actual number is. But mean does, because you're adding up all those values. And this is a very important concept for you to know, and know why we choose median over mean when your data is skewed. It's because mean is very sensitive to other values, whereas median, we call this a resistant value. This is resistant toward extreme values. So median is resistant, mean is not resistant. All right, let's look at number 1. Let's look at how to draw the histogram again. So what you do is that you go to second, y equal, plot 1 is on and other plot should be off. And it's always helpful to clear up all the y equal, or else you will see like different function and it will take a longer time because it's processing everything at the same time. And then histogram is the third option, although it depends on the calculator, it might look different. Now we're going to change xlist to L1. And then, and then we do second mode. And then we go to zoom 9. It says zoom stat. All right. This histogram is actually not that nice, although there are only 5 values, so that it's very hard to draw a histogram. So the histogram is actually more useful if you have a lot of values, like number 10. Number 10 has so many values here, right? So I might do number 10 with you guys to show you why histogram is useful in that sense. And this one, because there are only 5 values, so it's so like you can draw it on a dot plot, and then that's a lot easier way to see it than like this. This one also seems to be a little bit skewed. So let's check if the graph itself doesn't give you a lot of conviction of which one you should choose. You should always go to stat and for 1 bar stats and change to L1. Calculate. And so I'm gonna write median somewhere with green maybe. Median for number 1 is, mean for number 1 is 780.8. Let's look at what median is. Median is 781. Yes, mean is a little bit larger. So you could definitely say we choose median because mean is greater, which shows skewness, right? Skewed to the right because mean is higher. Or you can argue that this is not actually that different. And so we will use mean because this this data set is symmetric, but it's not really symmetric. And 833 is quite big compared to other things. But I think that is a tricky part of statistics. Sometimes you think, oh, it's only like, oh, it's a 10, like difference of 10. Obviously, that's a big enough difference. But like, how do you determine that, right? That's why we have this called measures of variation, which we are not going to get into. But you might ask that question, how big is big? How small is small? And there is a little bit of answer to that. Although you might say, oh, it's just arbitrarily, like it's subjective, like you decide or you decide kind of thing. But I mean, there are reasons why 10 might be not an issue in this data set, but it will be a huge difference in another data set. So we're going to talk a little bit more about that tomorrow. All right. So let's look at L2. So we're not going to look at the histogram first. We're actually going to just look at the one var calc, and then one var stats, sorry, and L2. Enter. So mean is 76.14, median 50.4. You know for sure this is skewed. That's a lot. That's a big difference. Oh, maybe not. We'll see. We'll see what this says. Not scatter plot. What is it called? Histogram looks like. So let's change it to L2. And then go to zoom 9. Again, there are only 5 values. Histogram is not the best way to look at things, but we have most of the... Oh, it's very clear, it's very skewed because like everything else is like 27, it's under 100, and we have a 194, which is like an extreme value. Another way to check extreme values is actually using box plot. So box plot can be drawn on calculator too, so I will show you quick. And this one helps you to like see whether there's an outlier or not. So how much is an extreme, right? How extreme does your data have to be as considered as an outlier? Well, there's a formula for that, but we're not going to get into that. But you can check it in your box plot. So choose the one that has a dot dot. So there are two options. The first one and the second one. Don't choose second one. Choose the first one always with the dot dot, and then do zoom 9. Let's see. This says there is no outlier. But again, there's only 5 data value. So do you see why having a lot of data is important? Because that's why, do you remember the project you did for exponential? I needed you to have at least 20 because that's the minimum amount of data you should have for any meaningful studies, okay? Like 5 is not very meaningful because you can literally just like look at individual people and do what you need to do. Usually statistic is more relevant to us or more practical when there is large population and we're taking a sample of them and then try to figure out how can we make a conclusion about the population using this 100 people. So maybe you are studying 10,000 people, but you're just collecting 100 of them, and then you're making a conclusion about the 10,000 people. So obviously it's not an exact science, but it does its job. Okay. So I think I'm gonna stop there in terms of today's lesson. If you understood mean, median, mode, how to find them. Mode again, let me show you how to do mode, even though I think it's quite easy. The only thing I can find mode for is like number 4 and number 3. So there is a repeating number, which is 61. So 61 is a mode for number 4. There could be no mode. So if there is no repeating value, everything happens only once, like number 1 and 2, there is no mode. Number 4, 61 is the mode, and number 3, 17 is the mode. And you could have multiple modes, like we talked about. Okay. So your homework will be on the next page. Just use a table as your data set. So enter the data set into your L1, L2, L3, and then do what I just did. Draw the histogram, do one var stats to figure out mean, median, and mode, you just have to count, okay? And then say which one is mean better option or median better option, and why you think it's a better option. So mean is only used when it's a symmetrical. And there is not much of a difference between mean and median. As soon as you see a big difference between mean and median, you want to choose median, and your answer is because mean is greater than median, or mean is smaller than median. Therefore, it's skewed to the left or skewed to the right. We should choose median. And mode, only use it if you have a multi-mode. And then tell me which one is a higher value in those different clusters. I hope this was helpful, and I think the lesson itself is not very hard, but there's a lot of background knowledge that had to go into it, and I have no way of knowing how much you knew before all this. And so I know lessons have been a little bit longer in the past 2 days, but hopefully the content itself isn't very difficult to understand. And I will see you tomorrow. And hopefully I won't have any technical difficulties tomorrow.